Hey guys, what's up and welcome back to Gem City Rail. You're currently looking at my test lighting fixture for the demo in this video, but before we get to that, a little bit of background. Most model railroads have on-off overhead lighting, and that's fine, there's nothing wrong with it. But I believe it can be more interesting, and I hope to prove that in this video. In my last video, I demoed my Chronost multi-realm synthetic and civil time ecosystem. That video was admittedly long and kind of boring, but it was going somewhere. This video represents one of the directions it was going. My goal with this new ecosystem that I'm building is to merge model railroading automation and CTC with theatrical light, audio, and other effects. In this video, I'm going to demo one element of that synchronized ecosystem: dynamic environmental overhead valence lighting. While Chronost functions as the master clock for my future model railroad, the application module that I'm debuting in this video, dubbed Chronolumus, is the first client application that relies on the presence of a Chronost master clock. Chronolumus is the application module that drives the dynamic environmental overhead valence lighting for my future model railroad. It uses a layers-based effects engine to create highly dynamic lighting. The base layer follows a location-aware, date-time-based day-night schedule driven by real-world solar and lunar cycles to provide primary lighting. On top of that, there are overlay layers, including probability-driven clouds that can roll through, and even thunderstorms. Sometimes it's overcast, sometimes sunny, sometimes in between. The forecast tonight calls for severe thunderstorms, so perhaps we'll get lucky and see one roll through. So let's go ahead and take a look at a demo. So what we're seeing here is a 1 meter test fixture on my lab desk. This fixture is being driven by a Quinn LED Digi-Octa brain board, which is controlled by the Chronolumus application. I'm going to start the clock now, running much more quickly than normal because otherwise this demo would be over an hour long. What we're going to see is Chronolumus deriving sunset, civil twilight, nautical twilight, and astronomical twilight based on individual locales defined as latitude and longitude points that are specified in the Chronolumus configuration along our 1 meter test fixture. To put that in simpler terms, the west end of this fixture represents Dayton, Ohio, and the east end represents Chillicothe, Ohio. You'll notice that as we're approaching sunset, the color balance is actually changing. Chronolumus is deriving gamma-corrected colors from the current date time to deliver effects like golden hour along the railroad. One of the coolest features of Chronolumus is that it is location aware. It isn't one-dimensional lighting, it's actually three-dimensional. In the test fixture, I have defined the west end as Dayton and the east end as Chillicothe. So we're actually seeing sunset travel from east to west along the line. As the sun sets on our railroad, you can see that we don't actually go completely dark. We have moonlight, based on the current real-world location of the moon for the set date and time. You can see that our thunderstorm overlay starts in the west. Storms in Chronolumus follow real-world storm tracks, in this case traveling from west to east along our hypothetical railroad. When combined with synchronized ambient audio overlays, like those which I've added to this video in post, you can likely see how this system can create exceptional immersion. Not only does it create immersion, but there's a lot of potential for real-world-like operational interest. I hope you found this video interesting, and if you'd like to follow along with this project, you know what to do. Thanks for watching, and I'll see you on the next video.